Hello student, welcome you all to online session. Myself Prerna Shinde from the Department of Chemistry, SVKT College, Devrai Camp, Nasik. So, today we are going to see the chapter crystal structure, the second chapter in the TYBSc from the semester 6. So, we are going to see the solids, their crystal structure, Bragg's equation, laws of symmetry, elements of symmetry, types of cubic structure and the numericals. In that we are going to see the how the solids get divided into the crystal lattices, Miller and Vici indices, how to draw the planes from the Miller and Vici indices and how to find out the interplanar spacing. So, basically there are solid, liquid, gases, three states of a matter. There are number of matters which is available in solid state. From that there is solid state chemistry. So, basically solids get divided into two parts, that is a crystalline solid and the amorphous solid. In a crystalline solid you can see in a picture there is a specific arrangement of the atoms. In case of amorphous solid there is no specific arrangement or irregular pattern or irregular arrangement of the atom. So, this is the image which shows the order arrangement and the in order arrangement. In the next we are going to see the basic difference between the crystalline solid and the amorphous solid. The crystalline solid have a definite characteristic shape. The amorphous solid do not have a they are irregular in shape. In a crystalline solid the arrangement of the constituent particle is in order manner. In case of amorphous solid there is no regular pattern of the atoms. Crystalline solid, as they have a regular arrangement of a constituent particle, they have a sharp melting point. Amorphous solid, they do not have a sharp melting point. When a crystalline solid you cut into with the edge tools, they split into two pieces and the newly generated surface are the plain smooth. In case of amorphous, when cut into the sharp edge tool, they form the pieces with the irregular shape. Here there are example, that is a copper and silver are the crystalline solid, glass and rubber plastic are the amorphous solid. Here is the source from which I have taken this image. Here again the 3D arrangement of what? The crystalline solid and the amorphous solid. Here you can see the arrangement of the crystalline lattice or the crystalline or the atoms. Atoms vibrate in a place in a fixed pattern. Atoms vibrate in a place more random arrangement. Therefore, amorphous solids have the properties like a refractive index, like electrical conductance, resistance are different in different direction. In case of crystalline it is the same. So, in a next in a solid there is a particular arrangement of crystal lattices. The smallest unit of crystal lattices, that is what? The unit cell. Here we can see the definition for the unit cell. The smallest repeating unit of a crystal structure in a 3D which shows the full symmetry of a structure. Largest units are chota sa part, that is what? The unit cell. There are 7 unit cell shape and the 14 Bravais lattices. Here is a structure which shows the crystal lattice, and from the crystal lattice, that is the smallest part is what? The unit cell. Here you can see the image unit cell where there is a x, y, z axis are denoted. Along with the x, y, z axis there A, B, C are the edge length, alpha, beta, gamma are the 3 angles created by these 3 axes. So, when the edge length get differ, there are on the basis of edge length and on the basis of that angle there are 7 different crystalline system that we are going to see. But basic structure of a crystal lattice is like this, that is at the corner, at the edge there is a single atom is present. On the basis of number of atoms present in a particular unit cell or particular crystal lattices, there are 3 types of a unit cell, that is a simple cubic system, body center and the face center. Here is a picture which shows the simple cubic. In a simple cubic system there are only atoms only present at the corners of the cell. So, 1 by 8 atom get divided in such a manner that it forms the 1 number of atom. Here you can see the picture of what? The unit cell, that is a simple cubic cell. Next is what? The body center cell. In a body center, as such in a simple cube there are 8 corners, so 8 number of atoms. So, 1 by 8 part get divided, so 1 by 8 into 8, so number of atom is 1. In a body center, exactly at the center of body there is a one more atom is present, therefore the name itself indicate the body center cell. So this is what the BCC structure. Here you can see there is a, at the corner there are 8 atoms, as the cube has a 8 corners and one number of atom at the middle of the cell. So this is what the BCC structure. Here you can see the FCC structure. FCC, that is a face center cubic cell or face center cubic structure. Face center, that is a number of atoms present or atoms present on the surface or the face of a cube. So cube has a 6 faces. So there are one face at each cube, but every unit cell is just divided with the 2 unit cell. So half of the atom gets shared with the one face. So here you can write 1 by 2 into 6. So there are 3 atoms from the faces and 1 by 8 into 8, so 1 atom. So overall in a face center cubic structure there are 4 number of atom. Here you can see again, simple cubic has a 1 number of atom, body center has a 2 number of atom and face center has a 4 number of atoms are present. So on the basis of edge length and the bond angle between the alpha, beta, gamma, there are 7 different crystalline system, and here is the source which I have taken this image. First is what the cubic, where cubic is a most symmetric system where A, B, C are equal and alpha, beta, gamma are equal to the 90 degree. In a first picture you can see that is a 8 number of atoms and there is the A, B, C which is equal in length. Next is a tetragonal. In a tetragonal you can write it as a where A is equal to B, that is a 2 edge lengths are same but third edge length is different or somehow is smallest or largest in a scale. So but alpha, beta, gamma are the symmetric angle which is equal to the 90 degree. Next is what the orthorhombic system. In a orthorhombic system all the edge length are differ but they have a same bond angle, that is the alpha, beta, gamma, but which is also equal to the 90 degree. Hexagonal, which is like a hexagon which has a 6 corner, again A equal to B which is not equal to C, alpha, beta are 90 degree, gamma is equal to the 120 degree. Monoclinic. Monoclinic, in a monoclinic system A is not equal to B is not equal to C, alpha and gamma is equal to 90 degree and beta is not equal to 120 degree. Next is triclinic, which is a most asymmetric system in a crystal lattices where the edge length are also different along with the bond angles are also different. So A, B, C are not equal and the alpha, beta, gamma is also not equal. Triclinic is the most asymmetric system in a crystalline system. Next is a trigonal. Trigonal system where the A, B, C are the same, alpha, beta, gamma which is not equal to 90 degree. Here there are 14 Bravais lattices. Here they have shown the P, I, F. I stand for body center, F stand for the face center and C stand for the side center. So there are 7 crystal classes. Along on the basis of that there are 14 Bravais lattices. All these things are mentioned in this figure. So this is all about the 7 crystalline system. Next we are going to see the Bragg's equation. Bragg's equation for determination of a crystalline structure or to determine the solid structure of particular element or particular surface. So what the Bragg law is about? Bragg's law said that the X-rays reflected from the different parallel planes of a crystal interfere constructively when the path difference is an integral multiple of a wavelength of a X-rays. Consider a set of parallel lattice plane of a crystal separated by the spacing d between each other as shown in figure. So here are the 3 lines are there. So what these 3 lines are indicate? These 3 lines are the arrangement of an atom and the atom get joined by the line. Therefore they said here that is a set of parallel line. Here the A and D are the incident beam, C and F are the scattered beam. The angle created, that is between the CBH, is the scattered angle. ABC is the incident angle. So this is the figure which shows the Bragg's from which we can derive the equation of Bragg's equation. Here is a picture which shows the derivation of a Bragg's equation. See here, the incident lines, that is LM and PQ are the incident lines. MN is a scattered line, LMN is a first angle, PQN is a second angle, that is a second incident angle. Along with this image, you can see the first ray travel with the distance LM plus MN as the angle created by LMN. That is a path length you can calculate, or you can write it as a LM plus MN. Second, the ray travels a distance PQ plus QM plus MN. So here are the two path length which just get added as the angle created by them. So you can calculate the path difference from these two equations, that is the addition of these two path length, that is a PQ plus QM plus MN minus LM plus MN. Next, just opening the bracket, the next line is PQ plus QM plus MN minus LM minus MN. So here there is a one more point, the distance of QM is equal to QR, therefore we can substitute it as a PQ plus QR minus LM. Again we can substitute one more equation for the QR. QR is nothing but the addition of QS plus SR. So I just substituted the value of QR as a QS plus SR. So you just get opening the off bracket, PQ plus QR plus SR minus LM. Again PQ plus QR, by addition of these two path length I will just get the one single line, that is a PS. So I substituted as a PS plus SR minus LM. As I know, PS is equal to LM, that is two path length, as it is a parallel beam. So I can write it as a PS equal to LM. So I just substituted the value of a PS as a LM. So LM just get cancelled and the path length is equal to SR. So where is the SR? Here. So angle created by this, that is a MSR or SMR. Angle SMR is equal to path length of MR. But what is the distance of MR? Is equal to 2D, that is a D plus D, that is AB and BC. It is what equal to the 2D. From that equation I can calculate, that is n lambda is equal to 2D sin theta. What is the n? That is the order of diffraction. What is the lambda? Lambda is the wavelength with which the wavelength with which light of incidence, wavelength of a incidence. 2D, D is the distance between the two interplanar spacing. Theta is the angle created by the incident angle created by the line. So here it is what the n lambda 2D sin theta. From this equation you can calculate the angle, that is a theta. You can calculate the interplanar spacing. So with the help of the XRD you can with the help of this equation you can calculate the interplanar spacing and the angle, solid angle created by the theta. So where it is used? The Bragg equation mainly used in the case of XRF, which is a X-ray fluorescence spectroscopy, or WDS, that is a wavelength dispersive spectrometry. Crystal of a known d spacing are used as a analyzing crystal in the spectrometer. Next application is the huge and the very important application of XRD, that is in a XRD, the interplanar spacing of a d spacing of a crystal is used for the characterization and identification of a purpose. So XRD is an instrument which can use the interplanar spaces. As we already seen, that is simple cube, body center and face center. Every cubic system follow a particular atom. That is, in a simple cube only the 7 line is missing. In a body center, cubic center, in XRD pattern there are only the even combinations are there. In a face center cubic lattices there are odd even combination. So from that data we can calculate, do it has a body center, do it has a simple cubic or face center cubic. So what we have seen today is the smallest recap of all this kind of thing, that is the repeating unit in crystalline structure is called as a unit cell. Simple cube contain the 1 number of atom, body center contain the 2 and face center contain the 4 number of atom. So this is all about today. The assignment for today lecture: how many number of atoms are present in face center and body center structure? What is the isotropy and anisotropy? Define unit cell, which is the most ordered system and which is the most asymmetric system. So as I already discussed in PPT, asymmetric, triclinic and the order arrangement. So this is what the assignment for the today's lecture. In the next lecture, we are going to see the electrochemistry. The next lecture is all about the electrochemistry, electrolytic cell, galvanic cell, Holtanic electrochemical, cell reaction, Nernst equation, and the standard electropotential series that we are going to see in the next lecture. Thank you.